we've got objectives all over the place. And basically we're kind of stuck right here at evaluate inverse tree functions because there are so many different ways to do them. And so far we've basically just been looking at cosine with inverse cosine, sine with inverse sine, tangent with inverse tangent. And one of the things I wanted to point out before we get to the tangent stuff today is right here. That's kind of a big deal with our composition of tree functions. Because here's what it's saying. It's saying no matter what you have in here, you don't really need to worry about the PDR with tangent because tangent and inverse tangent are just going to cancel each other out. But that's when tangent is on the outside. So what on earth does that mean? That means if we figure out which quadrant this is going to be in the PDR, and we take all the time to do that, we've kind of wasted time. Because it doesn't matter if it's in for tangent. Remembering our quadrants here. It doesn't matter whether or not it's in second or fourth quadrant, because in the end, we're just going to take the ratio of the two sides anyway. So with this one, what's special about it, and it's the only one we can do this with, is if we say, okay, the last thing we're supposed to do here is find tangent, then I don't need to worry about making a reference triangle. I don't need to worry about putting it in the PDR, because all I need is the ratio of the two sides. So it doesn't matter if it's going to land in second or fourth quadrant. That's the one special one that we have. Bless you. But notice for all of these, the last thing we're going to do is find the inverse. That means we have to have PDRs. So when we look at this set again, what was important about sine and cosine was, hey, if we're going to do this, this has to be between -1 and 1. With tangent, we don't have those restrictions, and these two will undo each other when you have inverse tangent as the first thing you're going to do and then tangent as the second. But if the last thing we're going to do is find the inverses, we have to use it. So the order becomes important when the outside parentheses are telling us that we have to find an inverse tree function. So that brings us back to here, which made that a really good place to go back and discuss what we've had for tangent already. So we're looking at tangent and inverse tangent. And I see, well, these, A, C, and D, all have inverse tangent as the last thing I'm going to have to do. That means I need PDRs for those. But this one, which quite frankly looks a little scary, these two undo each other. They're gone. Because it doesn't matter if it's in second or fourth quadrant. When we figure out what tangent is, it's just a ratio of two sides of a triangle, and it's going to be the same ratio no matter what. So now, let's go to the ones that are going to require a little bit more work here. Tangent of 7 pi over 4, like it says without a calculator, gets us thinking about our 30, 60, 90, 45, 45, 90. And we think of 7 pi over 4 as 1 and 3/4 pi. So if I want the tangent of 7 pi over 4, and I've got my 1 and 3/4 pi, that means I have a little pi over 4 left for that little position right there. And what's special about that? It's 45. So this will be a 1, this will be a -1, and this is going to be what? Yeah, we had a little confusion over that one yesterday. You know, in the 30, 60, 90, we have the 1, the square root of 3, and the 2. And for the 45, 45, 90, it's 1, 1, and the square root of 2. So we want the tangent of 7 pi over 4. And the tangent is going to give us opposite over adjacent, -1. So what we want to know is what angle would give us an inverse tangent, -1. Well, that means it has to have a tangent of -1. So is what we're looking at right now, does it have a tangent of -1? Sure it does. So we need this pi over 4. But it's got to be in the PBR because the last thing we have to do is talk inverses. So how do we label our little pi over 4 in the PBR? -pi over 4. Exactly. And like I said, B, because it doesn't matter what quadrant we're in, if we're going to eventually take the tangent ratio of two sides, it just cancels each other out. By the way, you're not going to see a lot of those in your homework, because we want the ones where you have to think through all the steps to get that. Let's go to C. Inverse tangent, where we have the tangent of -4 pi over 3. So how should we think of -4 pi over 3 in bracket? -1 and 1/3. And we realize that's going to give us a little pi over 3 right there. Okay, so there is our pi over 3, and we want the tangent of that angle. And pi over 3 is what in degrees? 60. So this would be square root of 3. This would be a 1. This would be a 2. And the tangent of -4 pi over 3, bless you, is the tangent that we get from that little triangle right there. So we need opposite over adjacent. So what would we get? Square root of 3? Is it negative? Yeah. Remember we talked about that before. That's easy to miss. Remember we're going left and up. So opposite over adjacent would be negative square root of 3. So now we go outside the parentheses. Remember math says innermost parentheses first, work your way outside. And I realize I need my inverse tangent to give me negative square root of 3. Well, I need it in the right quadrant. Which quadrant is that going to be in? It has to be in the fourth. Yeah, remember your PBR. It has to be in the fourth. So I've got to move my angle so that my tangent will be negative square root of 3. Well, that's opposite over adjacent. Just like that. Again, it has to be in the PBR. So what would we label that angle? Yep, that's what we do. Negative pi over 3. Oh, let's put the page after it. Because we need the same angle. It was giving us the same value. It's just we had to move it to the right quadrant. Alrighty. This one. How should we think of 19 pi over 15? 1 4/15 pi. Goodness. Okay, so 1 4/15. Got a little 4 pi over 15 here. Okay. 4 pi over 15. Good gravy. Is that one we even know? 4 pi over 15. Do we know that one? No. So we're supposed to figure out what the inverse tangent is for the tangent of 19 pi over 15. But is it even in the right quadrant? So let's put it in the right quadrant. And then when we take the inverse tangent, we'll be able to get what we need. So, why isn't it in the right quadrant? It's not in the PBR. All right. So, is that going to be positive or negative? I mean, we can't calculate it this time, but is this going to be positive or negative in this quadrant? So, which quadrant should we put it in to make this work? And what's the angle going to have to be in the first quadrant to give us the same trig functions? So we didn't really need to know what it was. So why go through all these steps? Because now we're going to start mixing and matching. And that's what was in the homework, where, okay, we've got a new sine, and we've got an inverse cosine, and then we have to mix and match. So these thinking steps that we go through with all of this help us when we get to those composition pieces. Because now we've got what? A whole page of, here you go, find them all. So away we go. We're going to find them all. Find the exact value of the following. Hold up. 3 and 5. That doesn't sound like a special 30, 60, 90 or 45, 45, 90. Maybe we better get a drawing. Maybe this is something we're supposed to know anyway. Even though it's not one of our 30, 60, 90 or 45, 45, 90s. Obviously, we're supposed to find exact values. We should be able to do this. Okay. So the inverse sine is 3/5. PVR for sine. What quadrant should we put that in? First. Alright, so there's my little angle theta right there. And it says the sine has to be 3/5. Sine is what? Oh, we're supposed to know that. What's the other side? 4. That's a 3, 4, 5. That's a famous Pythagorean triple. So we just set this triangle up so that the inverse sine is definitely 3/5. So this part is done. We just need to do this. So what's its cosine? 4/5. Wait a second. Is this any different than that? I'm not making a new drawing. What's the tangent? 3/4 opposite over adjacent. Make a new drawing for C? No. So cosecant. Ooh, that's tougher, right? What do you flip to get cosecant? Sine. So we're going to need hypotenuse over opposite. What would that be? So just because we don't see our beautiful numbers from our 30, 60, 90, and 45, 45, 90, it doesn't mean you throw in the towel and say, oh, I don't know, I'm going to do this one. You know, set it up, take a look at the visual, and see where you're at. All right, evaluate the following compositions without a calculator. Like I said, this is why our drawings for everything were so important. Because now we have to find the inverse cosine, which means we're going to find the angle that gives us this. And then once we find that angle, we're supposed to use it to evaluate the sine. Innermost parentheses out. Okay, wait a minute. Negative square root of 2 over 2. I don't think that's how that came to us. How would that have come to us in our triangle? All right. So inverse cosine means we have to be in the PVR for cosine. So think about that for a second. Where are we going to put the negative 1 over the square root of 2? Second quadrant. Good. And that was cosine. And what sides do we use for cosine? So negative 1 here and square root of 2 there. Makes total sense. Oh, well, do we need to know what the other side is, or do you already know what the angle is? Oh, okay. So we've got a 45, 45, 90, well, 45 degrees here. But if we name it, what's its name? 3 pi over 4. Everybody see it? Okay. So we really need the sine of 3 pi over 4. So, well, we know what the other side is, right? What is the other side? 1. And now we need the sine of that. Good, you're rationalizing the denominator right away. Good. So 1 over the square root of 2 will be the square root of 2 over 2. So innermost parentheses, work your way up. That's what we're always going to do. Alrighty, let's look at B. So B, we have to find the sine of 5 pi over 3. How do we think of that to get it graphed? 1 2/3 pi. 1 2/3 of the way. So can you tell me what our little angle is in there? Yeah. If you're thinking, well, it's pi over 3, yeah, but most of the time we think of that as 60 degrees. So we've got to know the side lengths, right? Opposite the 60 is going to be what? Negative square root of 3. And this would be the opposite of the 30-degree angle. So they want the sine of that. What would that be? Negative square root of 3 over 2. Okay. So we have to find the arc cosine. Negative square root of 3 over 2. Uh-oh, I think we have a problem. Inverse cosine would be in fourth quadrant for inverse cosine. Okay, where do we go? First or second for inverse cosine that's negative. Second quadrant, got to be over here. And we say, okay, well, if the cosine has to be negative square root of 3 over 2, cosine is from what side length? Negative square root of 3 over 2. And then most of us think right away, oh yeah, that would be a 1 making this what? 30 degrees. 30 degrees in terms of pi. Pi over 6. But with cosine, you have to name it from the positive x-axis, so it would be, yeah, that took some work. A lot of thinking steps to do something like that. Always remembering, okay, I need PVR if I'm going to be using that inverse in that last position. I have to have that PVR. Alrighty. Oh, this one looks interesting. Let's start with the cosine. Pi. How do we do that again? Good, good. Sometimes people forget about those quadrantals. Excellent. Okay, which one of those is the cosine? The negative 1, right? It's always cosine comma sine. So we want to know where you're going to get an inverse tangent of negative 1. Give me a quadrant where that's going to be. Quadrant 4 is where we'll get a tangent that's negative in the PVR. And if we want tangent to be negative 1, that's opposite over adjacent. What would the little angle be there in degrees? 45. But again, we have to label it in radians, and we have to stay in the PVR. So what would it be? Negative pi over 4. Good. There it is. So innermost parentheses, working out. Yes. We looked at this, and we said, cosine of pi, cosine comma sine, that's a negative 1. Then you have to totally stop thinking about this and just find where is my inverse tangent going to be negative 1. So you realize for tangent to be negative in the PVR, I've got to go in the fourth quadrant. And then you draw from there, all right, I need a negative 1 over 1. Oh, that's going to be an isosceles or a triangle. That's a 45, 45. Lots of steps, folks. Well, this one looks fun. So we want an angle, because that's our inverse sine or arc sine. We want an angle that's going to give us negative square root of 3 over 2. Is that okay? Did that come that way? Negative square root of 3 over 2? Yeah, that one's all right. You know, so we recognize that the 2 and the square root of 3 are both part of our 30, 60, 90 triangle. But we need this to be negative. So where are we putting it? Fourth quadrant. Leave it right there. Sine. What sides are you using? Okay. Makes sense that that would be a negative square root of 3 right there. So what would that angle be? 60 degrees in radians. Negative pi over 3. So now we're replacing this with negative pi over 3. Oh, well now we just need to find the cotangent. So we probably want to slap our little one right there. Cotangent. What side should we use? Adjacent over opposite. So what are we going to get? Good. Negative square root of 3 over 3, because we'll have 1 over negative square root of 3 and we'll rationalize the denominator. Rationalize. Sound like Elmer Fudd there for just a second. We'll rationalize. Alrighty. So let's go after E. Ooh, this one looks fun. Well, that's kind of silly. They just could have put sine of 0. But I want to make a sake for a second. So how do we do that? 1, 0. Okay, so we've got 1, 0. Which of those is sine? The 0. Man.
I have a question. So, like, some of these are actually determined in like incrementers, the other ones are ratios. How do you know?
The outermost one should tell you what your answer is going to be. Notice this is not inverse, so this is not an angle. This is a ratio. Remember, you start inside, work your way outward. It's always the outer one that tells you what your answer is going to be. Okay, sorry, you answered my question too. I got lost here. 0, right? Okay, so where's tangent going to be 0? That's 0. Yeah, because we do y over x, remember, for the quadrantals. 0 over 1, that's in the PBR. It's 0. It just takes a little bit of thinking about those quadrantals. Alrighty. So where do I start this one? 1 pi. Alright, so I'm over here. So what do I put? Negative 1, 0. What's my tangent? 0, y over x. So now I need to know, oops. Where will I find secant? 0. What's secant? Cosine flipped. All right. So flipping cosine, I have to think, well, where is that going to be 0? Because if cosine is 0, when I flip that, it'll be on the top. Where's cosine 0 when it's PBI? So we take a look. We've got secant here. We need that to happen. So if the secant of 0, we're out here. Right there. And cosine is going to be 1. So 1 over 1. Other ways to do this one. I was sitting here thinking this morning. This one is one that people tend to overthink. You could think of it as 1 over cosine. You could do it with the quadrantal angles, and remember that that will be r over x. You know, that kind of thing. And the radius is always going to be 1. So r over x, you'd be looking for what do you have for this cosine piece? 1 over 1. And that would give you that. Yeah.
So why is that negative 1? Because I think like that in that PDF, the laying down 0.
For tangent?
No, for
Okay, remember though, you're starting inside. We need the tangent of pi. We know what that is, so we find it. And then we say, stop thinking about that altogether. Just find the secant of 0. 1 over cosine. This is cosine at 0. 1.
well, why don't we use the negative 1, 0? Because tangent does not be a principal value. It's only
Take a look. Look for inverses. Are there any inverses in this problem? No. Don't need PDF. Only when your outside parentheses have inverses we said, let's find the tangent of pi. Tangent is going to be y over x. So it's 0 over negative 1, which is 0. But now we're done with the inside parentheses. And we say, okay, we need the secant of 0. What's the secant of 0? So we go over there to 0 and say, well, cosine is 1. Secant is what you get by flipping 1, and it's going to be 1. Make your overthinking. So careful. No inverse stuff going on up there. Alrighty, let's take a look at this one. Inverse sine of 0. Where's sine 0? That's 0. So we want the inverse cosine of 0. So that means we're looking for an angle that'll give us 0 for its cosine. Got to be in the PVR because it's inverse. Where are we going to find that? And give me the label for that angle. Pi over 2. There it is. Pi over 2. This one's kind of weird. Look at that. They want us to do some math after we've done the inverses here. Okay. Inverse cosine of, oh, they're messing with us. 0.5 is 1/2. So we want to find where that inverse cosine is 1/2. So what quadrant should we go into that? Quadrant 1. For cosine, what sides do we use? Okay, so is that enough? Do we know what that angle is? What is it? 60 degrees, which is pi over 3. And now, we're saying we have to take 2 times that. So we're replacing this with 2 pi over 3. And we have to find the sine of that. Okay, so 2 pi over 3, well, that's over here. Us that 60-degree reference angle. So this is going to be the square root of 3, but we have to be careful and put our little negative 1 there. That 2 there. So what's our sign? Square root of 3 over 2. Oh golly, look at I. Which makes me think maybe I better check the time. Oh, we're good. Sine of 3 pi over 2. Oh. Where's 3 pi over 2? Ooh, straight down, huh? Ordered pair for that? 0, negative 1. Which one of those is a sine? Negative 1. So now we're going to find the secant of the arctan of negative 1. Inverse tangent. Now we need PVR. Where are we going to find the tangent of negative 1 in the PVR? Fourth quadrant. How are we going to get negative 1? 45, 45, 90. Okay, arctan means we're supposed to give them that angle, but it needs to be in radians and it needs to be in the PVR. So what's it going to be? Negative pi over 4. So now we're supposed to tell them the secant of negative pi over 4. Oh, that's not so bad. We already have the triangle drawn. All we need is the hypotenuse. What's the hypotenuse? Square root of 2. Okay, think through it. What do you flip to get secant? Cosine. So we're going to need hypotenuse over adjacent. So what's it going to be? Right there. So step, innermost parentheses out. Just kind of stop and think, what am I finding here? What am I supposed to do? Oh, and this gives us a brand new topic here. We should stop. So I think you'll be able to do a large portion of B2 now. And both Mrs. Peterson and Mr. Bloom are gone today. So we are not certain that the test is going to be next Friday. Unfortunately, and it might just be one of those things where I say, hey, if we can get there in time, we'll take the test on Friday. But I know they're going to want to push it back probably to Monday. So we'll see. Maybe they'll let me kind of run my own. Do that on Friday. Monday tests are tough, but it also gives you more time to study. Oh, we were earlier.